All right, so this is going to be a lesson on ionic bonds and how to write their chemical formulas. So let's review just a few things we had covered in class regarding chemical elements. So in class we've talked about the Bohr models, and I'm going to review the Bohr model with you for 3 elements. There's beryllium, there's fluorine, and then there's chlorine. And then continue on by showing you a new method called the Lewis structure. So to start off with, we have beryllium right over here. It has an atomic number of 4. That tells us that we have 4 electrons, so I'll just write myself a little note of 4 electrons. And in the Bohr model, you remember you are writing the chemical symbol. The first shell can only hold 2 electrons, and then the second shell can hold up to 8. I have 2 of the 4 in my first shell, and I have 2 left. So this means that we have right now 2 valence electrons. All right, I can actually draw this in a different structure, which we call the Lewis structure. So just as a reminder, this is the Bohr model. And the Lewis structure is essentially the same thing, where you start with the chemical symbol. We're going to start with beryllium symbol on the bottom, but this now entails just placing dots of how many valence electrons I have. So I know I have 2 valence electrons. That means that I start with 1 dot on top and then move down to the next dot on the bottom. And this device doesn't let me draw dots, so I'll just write little tags here. So this is the Lewis structure of beryllium. Let's try another one, fluorine. So fluorine, if you look at the periodic table, has an atomic number of 9. That means we have 9 electrons. So in this case, in terms of the Bohr diagram, I draw 2 electrons in the first shell, and I'm left with 7 in the second shell. And I'll just write little tags for that. Okay, so again, I'm going to remind myself I have 7 valence electrons. To create a Lewis structure of this one, I'm going to again write the chemical symbol. And this time I want to make sure that I draw 7 valence electrons. And the way that I do it is I start with the north, then go to the south, east, and west. Okay? And I should be drawing these as dots. It's just that my computer doesn't let me do that. So far I have 1, 2, 3, 4, 5, then continue on to the south, 6, and 7. So that is what the Lewis structure looks like for fluorine. So you notice that you have these pairs of electrons. These are a pair of electrons. And you have a pair here and a pair here. This one is a single electron. So this is telling us the site where this element can bond to get that other electron. Let's try chlorine. Chlorine has the atomic number of 17. If I draw chlorine quickly, again, Bohr model, 2 electrons in the first shell. We have 8 in the next shell. And then in the last shell, we have 7. And that works out to be 17. Okay? So same thing. Remember, we're just concerned about the valence electrons. The valence electrons for chlorine, there are only 7 valence electrons. And so that our Lewis structure is essentially going to look exactly like the one of fluorine, only this time you're going to have chlorine in the center. And again, 1 electron north, south, east, west. Then I go back up to north, south, east, and here is the one location where this atom can bond. These are called Lewis structures, what we've drawn before. And these Lewis structures allow you to be able to predict how each of these elements is going to behave when there are other different elements around it. So just a quick sort of reminder on the periodic table. Remember when we did our activity that the first column has 1 spike. That tells you you have 1 valence electron. I'll just write VE. Here we have 2 valence electrons. Here we have 3 valence electrons, 4, 5, 6, 7, and 8. Okay. So the next part of this is that all elements have something that's called noble gas envy, and they like to have a full valence electron shell. So they would like to have either 8 electrons in their valence shell or 2. So let's take, for example, something like lithium. Lithium has the atomic number of 3, so that tells us that we have 2 electrons in the first shell and just 1 in the next shell. So lithium has only 1 electron. It wants to get 8 or have a full valence shell. It's going to be really hard for lithium to gain 7 more. So what lithium will do instead is it will have a tendency to lose that electron. And if it does, if it loses that electrons, it's now looking like this and has a complete valence shell. Remember, the first valence shell is just 2. On the other hand, chlorine is going to have 7 valence electrons in its shell, and it has 2 shells. 1, 2, 4, 5, 6, 7. And if that lithium will give its electron right over here to that chlorine, it now has a full valence shell. This is a win-win for both. The lithium has lost its extra electron, it now has a full valence shell, and the chlorine has gained 1. This is a chemical reaction that's happened right here. So in general, what happens is if an element has 1 to 4 valence electrons, it will lose them. If an element has 4 to 7 valence electrons, they will gain electrons. You notice that both of these are 4. We won't go into, in general chemistry, when do they lose and when do they gain. I will always tell you which they will do. It has a lot to do with electronegativity, but that goes beyond what we're going to be doing. So for the next part, let's see how we can actually have these chemicals bond. Now, to start off with, an ionic bond is the bond of a nonmetal with a metal. Okay, so here we have lithium. Lithium is a metal. And we have oxygen, which is a nonmetal. So when these two bond, they will form our ionic bond. So we'll start off by drawing these out a little bit. So lithium, I like to always draw the Lewis structure. Remember, has just 1 electron in its valence shell. Oxygen, on the other hand, if I draw the Lewis structure of oxygen, has 6 valence electrons in its electron shell. So, there we go. So what can happen in order to get that valence, that noble gas envy, is that the lithium can move its electron, let me use a different color pen, can move its electron to oxygen and actually gives it away. So it loses its electron. That means that lithium now has 3 protons, and it just gave 1 away of the electrons, that it now has 2. And remember, that means that protons, you have 3 positive charges, where with the electrons, you now just have 2. If I do the math, you'll see that this element now has a +1 charge. And what we're going to do is write that plus right up here as a subscript. So lithium is now a plus charge. Oxygen, on the other hand, has just gained 1 electron. Okay? So now it has just become more negative. For that reason, This oxygen has 8 protons and now 9 electrons. So that's 8 positive charges, 9 negative charges. That makes this one a -1 charge. So we're going to write on top here, -1. Okay? So whenever you have a positive charged ion, we call those cations. The way that I remember it, cats are cute, they give you positive feelings. Anions looks a little like onion, which makes you cry, and that's sort of a negative feeling. So anything that has a negative charge is called an anion. So let's try a few of these here and see how they can actually combine together. Let me start with beryllium and sulfur. So this is beryllium. Beryllium, if I write its Lewis structure, is Be with a dot, dot. And sulfur has a Lewis structure where you have 6 valence electrons. All right. Now you notice that this one has 2 electrons. It wants to get rid of those 2 electrons. So what it's going to do is it's going to find an anion that can take those. And it just so happens that this sulfur has a space for 2 electrons. So now 1 electron will be here from the beryllium, and another one of those electrons is going to come right here. So sulfur now has 8 valence electrons, exactly what it's hoping for, and beryllium has a full shell of 8 beneath that. So we would now write these together because these are now bonded as beryllium, BeS. We're going to have, and this here is a chemical formula. Now it gets a little bit more complicated than this. What happens when you have ones that do not correspond one-to-one? So let's instead use, for this one, lithium and oxygen. Lithium, remember, we said had 1 electron in its valence shell. Oxygen had 6. So take a look. This lithium can lose 1 electron and give it to oxygen. So now oxygen has 7. It's still not happy. It wants to have 8. So if we add another lithium, and we can do that, that has 1 extra electron, that lithium can transfer its electron to the oxygen. So now we have 2 lithiums, and we have 1 oxygen. Because they're now bonded together to look like something like this here. Here is my oxygen, and here is my lithium, all bonded together. We call this lithium 2 oxide. We always write the anion first, the cation first, and then the anion. So let's see if you can try a challenging one. The next one being, let's get a new slide. Try now one that is aluminum and oxygen. See how you would bond those together. That will end our lesson.